Welcome my dear student. Welcome to my channel Talking Physics with Piyas Sarkar. So today we will discuss about the first chapter of class 12, that is electrostatics. Electrostatics. So what will we discuss today, or what will we learn today? If I say you that how can I prove that which force is greater, electrostatic or gravitation, then what will be your answer? I know everyone you say that electrostatic force is greater than gravitational force. But if I say you, could you prove it? Then how? Please write in my comment box. So today we learn about the strongest force. Which is strong, electrostatic or gravitational? Number 2, which we shall learn, is what is stable and unstable equilibrium. We know that if the total force on a charged particle or body is 0, then the particle will be at rest, and it is called in physics language equilibrium position. But for a charged particle under the electrostatic force, is it be stable equilibrium? That is, if it remains stable or unstable. How can we discuss it? How can we prove it? And another is, what is the similarities and dissimilarities about the gravitational force and electrostatic force. So don't waste your time. Let us start our new topics, electrostatics. So at first we look to the Coulomb force F, that is the force between two charged particles Q1 and Q2 separated by a distance r in air, is written as F equal to 1 by 4 pi epsilon naught Q1 Q2 by r square. So this is the force. This force may be, this force may be attractive or repulsive on the base of this charged particle. If Q1 Q2 is of same sign, then F will be repulsive force, and if Q1 Q2 will be the opposite sign, then the force will be attractive force. I know you know this very well. Now my question is, you know also the form of Coulomb law in CGS and SI unit. We do not discuss the Coulomb's law because you know this in about the Coulomb's law is formed in, you have already read in class 10. The Bengali medium student, also the English medium student will read it already. So here we discuss some extra thing. Now what is the dielectric constant or permittivity? What is the significance of it? So what is the permittivity or dielectric constant? If we put Q1 Q2 in air and the distance of separation between them is r, then the force exerted on each charged particle will be 1 by 4 pi epsilon naught Q1 Q2 by r square. But if we immersed charge Q1 Q2 in water, then what will be the force of them with respect to air if we immerse them in water? So the force of water will be how much? So in case of medium, this equation can be written as 1 by 4 pi epsilon Q1 Q2 divided by r square, where epsilon is called permittivity of the medium permittivity of medium, and epsilon naught is permittivity of free space. Now, if we say it, if medium, not only for water, for any medium, this will be true. Then if we divided equation number 1 and equation number 2, then we get if this is, we say f air, then we can get f air divided by f medium equal to 1 by 4 pi epsilon naught q1 q2 by r square, 4 pi epsilon naught q1 q2 by r square is cancelled in each case, so we can get 1 by 4 pi epsilon naught divided by 1 by 4 pi epsilon, that is epsilon by epsilon naught, which can be said as k. Now this k is called dielectric constant of the medium. So in terms of permittivity, we can define dielectric constant medium is the ratio of permittivity of the medium to the permittivity of free space. So as we know that f air by f medium equal to k, then we can get the force f medium equal to f of air divided by k. That is, the permittivity of the medium influences the force of this particle when they are situated in another medium except air. For example, permittivity of medium, we know that permittivity of water is 80 with respect to air. Permittivity of water, that is K water, permittivity of water equal to 80 with respect to air. So the Coulomb force in water is Coulomb force in air divided by 80. So the permittivity is the value. If we know the permittivity of any medium, then we simply divided the force in air divided by the permittivity of the medium to get the force in that medium. This is the law. F water equal to F air divided by 80, as the permittivity of water is 80. So in case F medium is equal to, we know, F air divided by K. We can define in terms of force the dielectric constant is, it is the ratio of force in air divided by force in medium, that is the ratio of the force between two charged particles in air to the force in medium, or it is the ratio of dielectric constant or permittivity of the medium to the permittivity of free space. So we can know the significance of K, that is relative permittivity or dielectric constant of the medium. Please note down it. This will be very important for you. Now we shall go with some similarities and dissimilarities of gravitational force and electrostatic force. I hope you have already read this. So we can go with at first similarities. Number 1, gravitational force is given by F is equal to G, that is universal gravitational constant, m1 m2 divided by r square, and F electrostatic force is K q1 q2 divided by r square. For SI value, K equal to 1 by 4 pi epsilon naught. So both the force is, so the force of gravitation is directly proportional to the product of the masses, and force of electrostatic is directly proportional to the product of the charge. Both the force are inversely proportional to the square of the distance between them. Both force are along the line joining the particle, that is both gravitational and both electrostatic force are acted along the line joining the charged particle or joining the masses. So this will be the similarities between the gravitational force and electrostatic force. Now we go with some dissimilarities. gravitational force. Now we go with dissimilarities. Dissimilarities. Number 1, gravitational force is always attractive in nature, but electrostatic force is either attractive or repulsive based on the nature of the charge particle. Okay. Number 2, gravitational force, we can write it as GF. Gravitational force is independent of medium. Whichever the medium, the gravitational force is same. But electrostatic force depends on medium, as we can show that F medium equal to F air divided by the dielectric constant K. So gravitational force is independent of medium and electrostatic force depends on medium. Number 3 is Fe is greater than Fg, that is electrostatic force is greater than gravitational force. I say you in the starting of this video that how can you prove this? Everybody or all of us rub our hair through a comb, and then if we take a piece of paper, then we can easily uplift the piece of paper by the comb. So on that case, the gravitational force is pulled down the paper towards the downward direction, but the electrostatic force is able to lift it in the upward direction. So we can lift a piece of paper by a comb. So it proves that the strength of electrostatic force is greater than gravitational force. A famous scientist, Feynman, said that if two pupils are situated on Earth's surface at a distance arm length, their arm length means this distance. At the arm length distance, and if person A and person B, person A has electron 1% than proton with respect to person B, that they both are not electrically neutral. Person A have electron 1% greater than proton than person B, then the repulsive force acts between A and B. Repulsive force act between A and B is easy enough to lift the entire Earth. Again I say that if two bodies, 2% are situated at arm length from one to another, and two man has the same number of electron and proton, and if we get an excess electron to person A, just 1% than proton, then repulsive force will occur between A and B. So this repulsive force is enough to lift the entire Earth according to Feynman. In this way we prove that the gravitational force is weaker than electrostatic force, or electrostatic force is much stronger than gravitational force. So now we go with some numericals to clear our concept. Okay, I hope you will know some good points from my lecture. A charge q is divided on two objects. A charge plus q is divided on two objects. Plus q charge is divided on two objects. What should be the value of the charges on objects so that the force between the objects is maximum. Total charge is Q. It is divided between charge particle A and B. Now the question is, what should be the charge? What should be the values of the charges on the object? What should be the values of the charges on the object so that the force is maximum, electrostatic force is maximum? How can we solve this? Suppose this is Q1 charge and given is Q2 charge. The total charge is Q is divided as Q1 and Q2. Then what will be the value of Q1, Q2 so that the force is maximum between these charge particle? Okay. I hope the problem is clear to you. If you know the answer, then write my comment box. I will give you 2 minutes to do the same. Okay. So, suppose we give a fraction of charge small q to A, that is Q1 equal to small q, so Q2 equal be Q minus Q. So, the force will be 1 by 4 pi epsilon naught Q minus Q into Q divided by R square. I hope you understand it. Now, to be force to be maximum, force to be maximum, we get df dq equal to 0. I know you know the differentiation and maxima. To find out the maxima minima, you have already do it class 11. So, df dq equal to 0. So, if I derivative the equation 1 with respect to q, then 1 by 4 pi epsilon naught into 1 by r square as the constant term, it will be outside the derivation, then dd cube of q minus q square is equal to 0. As this term is not 0, so this term is 0. So, ddq of q means q minus 2q equal to 0, or small q is equal to q by 2. Small q equal to q by 2. So, the charge is equally distributed between the particles so that the force will be maximum. The charge is equally. The particle A is get q by 2 charge and this is q by 2 charge. So, the force is maximum. Okay. Next we go with the very interesting topic for today, that is stable or unstable equilibrium. What is stable equilibrium? If a particle is displaced from equilibrium position, if a particle, suppose this is q and this is q2, and if a third charge particle small q is situated in the middle of q1, q2, and if we slightly displace it from its equilibrium position, as we say it as equilibrium position. So, as we displace it from position A to position B, that is from this to this point. Now, if it coming to its original position A after displacing, then it is said stable equilibrium. That is, after displacement of charge particle, if it returns its original position or initial position, then it is said to be stable equilibrium. And if we go away from the equilibrium position after the displacement, then it is called unstable equilibrium. So, if we particle shift towards the equilibrium position, that is towards equilibrium position, is called stable after displacement of charge particles. And if away from equilibrium position. This is called unstable. Okay. So we can do it in numericals and try to understand. I hope the topic is quite interesting to you. If you know, if you want to learn more things, interesting facts, then subscribe to my channel. I will give all the details, syllabus of 11 and 12. My channel is very new, so I am trying to level my best. Okay. Now, 2-point charge 4E and E are fixed at a distance A. 2-point charge 4E and E are fixed at a point A. Fixed at a distance A. The distance is A. Total distance is A. Where should a third point charge Q placed on the line joining the two charges so that it may be in equilibrium? Where should a third particle Q, third point charge Q is placed so that on the line joining the two charges so that it may be in equilibrium? So, for this particular problem, suppose we place a point charge Q is at a x distance from 4E charge, then it will be a minus x distance as the total distance is x. Okay, I forget to tell one thing that the Coulomb's law is applicable for point charges only. Okay, what is point charge? Now, if the particle size is much smaller than the distance of separation between them, if the distance of separation is r and the particle size is d, then if d is much less than r, that is the size of the particle is much less than the distance of separation between them, then this charge be said point charge. It is also go for point mass. Okay, there the size of the mass will be much less than the distance of separation. So these two charge will positive. So if we do not put Q, then a repulsive force will establish between this, and these two charge will separate it. Plus 4E push a force along this direction and E put a force in along this direction, and they will be not in equilibrium position. But we have to stay these two charge particle in equilibrium position by the third charge small q. So in this case, if we take plus q charge, it will be minus q. Okay, we say that, we assume that this charge is plus q. So the repulsive force between 4E and q must be equal to the repulsive force between E and 4q. If the repulsive force between 4E and q, so the repulsive force of 4E and q must be equal to repulsive force of plus q and plus E. So the two charge will be at equilibrium position. This will be a distance x. So 1 by 4 pi epsilon naught 4eq by x square must be equal to 1 by 4 pi epsilon naught qe divided by a minus x square as per Coulomb's law. Okay. So this direction, the force exerted on q by 4e is F1. So the direction of F1 is along this direction as the force is repulsion, and the force between plus E and plus Q is F2. F2 acts along this direction. I hope you understand the direction of force. As they are two repulsive force, so the direction of F1 along right side, the direction of F2 along left side. Now 4 pi epsilon cancel, and EQ is also cancel. So you can get that 4x square, sorry 4, we can get EQ cancel, therefore we can get x square equal to 4a minus x square, 4a minus x square, okay. X square equal to 4a minus x square, or x equal to plus minus 2a minus x. So if we take the plus sign, then we can get x equal to 2a minus 2x, 2x takes 3x equal to 2a, or x equal to 2/3 a. If we take the minus sign, then we can get x equal to minus 2a plus 2x, that is x equal to 2a. So we can get two values of x. This is not possible because if we place the charge to a distance, a is the separation between them. If we take the charge to a distance, then it will not be able to keep the charge 4e and e in equilibrium position. So we can get x equal to 2a, that is the charge q is placed at a distance 2/3 distance from 4e particle. So x equal to, we can get 2/3 of a, that is the 2/3 distance of total distance, that is a. Now what is stable and unstable equilibrium? So if we take this charge q a little, if we can slide this charge q a little position towards right, that if we take q from position x1 to position x2, then what will be occurred? This can be shifted in this position. Then the force F1, that is the force between 4e and q, the force F1 will decrease, F1 will decrease because distance increase, and F2 will increase as distance decrease. So a net force F2 minus F1 acts along left side, because the direction of F2 along left side and direction of F1 along right side. So the net force acts along left side. So it brings the charge particle q to its original position at x1. So this is the case of stable equilibrium. Okay, if we shift this q by a position, by a little distance to the e, then the charge particle will come back to its initial position due to the F2 minus F1 force. This is known as stable equilibrium. But if we put a charge particle minus q, if we say that the sign of q is minus, that is a negative charge particle is placed, and e, then what will be the direction of F1, F2? As in that case, this will be force of attraction, then F1 will be directed along left side and F2 will be directed along right side. Thus just the reverse of the previous phenomena, okay? Because the force of attraction 4e attracts q towards left, and also e, as this positive, this is negative, so also this attracts F2 along right side. Now if we shift minus q to this, then again F1 decrease and F2 increase. But here the F2 minus F1 acts along right side, because the direction of F2 here now is on the right side, not the left side. So the direction of the net force, okay, the direction of net force becomes to the right side. That is, the charge particle cannot come to its initial position, it can move away from the initial position, as we said earlier that it is the case of unstable equilibrium. Okay, so I hope you really understand. If don't understand, pause the video slide back and then see again and again. I say you definitely will catch the problem. Okay, so for the next day we can do the system of charge particles and the force on a charge particle due to system of charge particle and the related maths, that is the charge in the triangle vertex or the vertex of a square and so on. So for today this is I have quite done, and for the next interesting video keep watching my channel and subscribe. Thank you.